Now, there are some properties of matrix multiplication that do still work. Those properties are the associative property, which states if we take matrices A and multiply it by matrix B, and then we multiply that product by matrix C, that's the same as saying we take matrix A and then multiply that by the product of B and C. We've also got the associative property of scalar multiplication, which says if we take a constant and we multiply it by the product of matrices A and B, that's the same as saying we can take the constant times A and then multiply that by B. And it's also the same then if we take matrix A and multiply it by the product of our constant and matrix B. That's fine. We've also got different distributive properties. So we can say we've got the left distributive property, where we say if we take matrix C and multiply it by matrix A plus matrix B, the result is C times A plus C times B. So if we've got a left distributive property with matrix multiplication, we also have a right distributive property. Which says if we take A plus B and then multiply that by C, it's equal to AC plus BC. Alright, now I've got some application examples. So if we move on now to example 18, it is a word problem. So the first table shows the number of reams of paper, packs of dry erase markers, and boxes of staples requested by 2 different teachers. The cost per item is given in the second table. We're going to write these as matrices and use matrix multiplication to show what is the total cost of the supplies for each teacher. So if we take that first table, we can write it as a matrix where we're going to have 6, 4, 5 as the first row, and 8, 2, 3 as the second row. So we have a 2 by 3 matrix. And then in the second matrix, we're going to have just a column matrix. We're going to have 15, 4, and 2.5. So since we've got a 2 by 3 and a 3 by 1 matrix, we're going to end up with a 2 by 1 matrix. 2 rows, 1 column. So we're going to go 6 times 15 plus 4 times 4 plus 5 times 2.5. And then we're going to go 8 times 15 plus 2 times 4 plus 3 times 2.5. Now we can multiply. So in our first row, we're going to have 90 plus 16 plus 12.5. In the second row, we're going to have 120 plus 8 plus 7.5. And now if we add, we're going to find out that Mr. Smith spent $108.50, and then Mrs. Wills spent $135.50. So what we can do is kind of like a sentence statement. I'm going to put it up at the top of the screen in blue. We can say that Mr. Smith his total is $108.50. Let's change that to a dollar sign. And Mrs. Wills, her total is $135.50. And let's put a dollar sign there. So we're done with example 18. We're going to move on. And the examples 19 through 22 utilize the same thing. So to start, we're looking at students at Oak Hill High School. They're selling bags of popcorn for $10 each, tubs of cookie dough for $12 each, and baskets of fruit for $16 each to raise money for the school. Now the number of each item sold per class is shown in this table. Example 19 asks if they earn 15% profit on each item they sell, we're going to use matrix multiplication to show the profit earned by each class. And we're going to give our answer as a matrix. So the first thing we need to know, what's 15% of each of those dollar values? So we're going to take and go 10. I'm going to save this space at the bottom. I'm going to go in this blank space in the middle of the page. 10 times 0.15, 12 times 0.15, and 16 times 0.15, and figure out what's 15% of each of these different items. Well, 10 times 0.15 is 1.5, times 12, we're going to get 1.8, and times 16, we're going to get 2.25. So we can set up a matrix where the first one has 4 rows, 3 columns. Our first row is 60, 84, 45. The second row is 75, 58, 28, 40, 63, 18, and 91, 47, 32. And we're going to multiply that by 1.5, 1.8, and 2.25. Now if we do that, we're going to take the first row and we're going to multiply it by that matrix. We're going to have 60 times 1.5. We're going to have plus 84 times 1.8 plus 45 times 2.25. We're going to have 75 times 1.5, 58 times 1.8, and 28 times 1.8. Then we're going to have 40 times 1.5 plus 63 times 1.8 and 18 times 2.25. And I made one mistake in my previous row. Instead of 1.8 times 28, I should have written 2.25. And then the last row is going to be 91 times 1.5 plus 47 times 1.8 and 32 times 2.25. Now I've run out of space, so I'm going to move on to the next page to put my next piece of work. So if we do the multiplication, our first row is going to end up being 90 plus 151.2 plus 101.25. Our second row is going to be 112.5 plus 104.4 plus 63. Our third row will be 60 plus 113.4 plus 40.5. And our last row is going to be 136.5 plus 84.6 plus 72. Which now, if we add these numbers, we're going to find out that the freshman class raised $342.45. The sophomore class raised $279.90. The juniors, $213.90. And the seniors with $293.10. We wrote our answer as a matrix, just like the question asked. Now, we are going to, in example 20, the question is, which class earned the most profit? Well, the answer is the freshman. Example 21, give the total profit for the school. So if we add up everything we got in our answer to example 19, we'll see that the total profit the school made was $1,129.05. And then our last example, 22, how much more profit did the seniors earn than the juniors? So if we take how much the seniors earned and subtract how much the juniors earned, we see that the difference is $79.20. And that wraps up our lesson on matrix multiplication.